Welcome back to Mathematics Made Easy, Volume 2, Part 2. Here we'll be learning exponential equations, or you say indicial equations. So you can see it as exponential equation or indicial equation. What are exponential equations? Exponential equations are equations in which the unknown is the index, or you say power. So an equation with unknown power or index is what we call exponential equation or indicial equations. For instance, if I are given, let's say, a raised power x equals a raised power y, what makes this an equation? The equal to sign, right? Now, this is an example of exponential equation. Why? It's having indices there. And in this case, whenever I come across equation of this form, the rule says that once both sides of the equation are of the same base, you simply equate the power. So this one, the law says, whenever you come across equation like this, and both sides of the equation are of the same base, you equate the power. That is, x will simply be what? Equals to y. For example, if I'm given, let's say, 2 raised power x equals to 2 raised power 2. This is an example of exponential equation. Since both sides of the equation are of the same base, what is the rule? It means for you to find s here now, you simply say your x is equal to what? Is equal to 2. So in some cases, the number given might not be of the same base. But if you check, notice that there's a way you can express the two sides of the equation to be of the same base. In this case, you first try and condense, like 8 now means 2 raised power 3, 2 multiplied itself 3 times. You see that I've condensed 8 to 2 raised power 3. So they're now of the same base. So it's just like the law. So what we just do, it implies that your s is what? Your s is 3. So let us consider some technical examples. So if I ask to solve for s now, let's say solve for s if you have square root of 3 raised power x equals square root of 9. To solve this is very simple once you know what you are doing. Now we are given square root of 3 raised power x equals square root of 9. You are seeing square roots at both sides. The first thing I do is to eliminate the square roots. And how can you eliminate square roots? You take square of both sides. So the first thing is take the square of both sides. So we are having square root of 3 raised power x squared equals square root of 9 squared. So the square root cancel the square root to eliminate. So the left with 3 raised power x equals 9. You can see now is in form of exponential equation. So what I want to do is you expect both sides to be of the same base. Let's try and condense 9 to be of the same base with this, and how? That is 3 multiplied itself 2 times 3 raised power 2 is 9. You can see that. So they are of the same base now. So that implies that what x is simply equals to 2. And that is the final answer. Let's consider another example. If I give you more complex one, like 1 over 81 y, 81 raised power y plus 1 equals, let's say, 9 raised power y minus 2, like this. And you have to find the value of y. If you take this equation now, you realize that you can condense the numbers involved to the same base, but the power will be different. So like 81 and 9 now. I want to make the equation to be in the linear form. It should not be having inverse like this. You know, from negative law, if you have inverse, it means negative power. I can simply change this one back to 81 raised power minus into. That minus will affect everything. Notice the power, both y plus 1. So y plus 1. This one will still give us this one back. I just want to make it to be in the same form. You can see that now. So the next thing I'm going to do here is you condense the number to be of the same base, like 81 and 9. 9 now, you know, is 3 raised power 2, 3 multiplied itself 2 times. What about 81? 3 raised to power 4 will give us 81. 3 multiplied itself 4 times. So they are having 3 raised to power 4. But don't forget that there is negative here, so you split say minus 4 like that. And instead of affecting y plus 1. And this one is what? 3 raised to power 2. And the 2 will be affecting what? Y minus 2. I think you can see that now. So next step is to expand. We open the brackets. So we're having 3 raised to power minus 4 will affect this and to affect my plus 1. So minus 4 times 1 will be minus 4y, then minus 4. equals, similarly 2 we have had 2 times y is 2y applied to, that will be 4. So there will be same base. What did I say? It implies that the power will be equal. So there will be minus 4y minus 4 equals 2y minus 4. Don't waste your time here. Collect the like terms. Simply collect the like terms by taking the other to one side and numbers to the other side. So there will be minus 4y. 2 to this side will become negative, minus 2y equals, we are left with minus 4 here. If that one should go to become plus 4. I really can see that now. So what's minus 4y minus 2y? Minus 6y. And minus 4 plus 4 is 0. So what are you going to do here? You divide both sides by what? By minus 6. The coefficient of the unknown. And y will simply be what? Y will be 0. So the value of y here is 0. Let's consider another example. If you are given, let's say, 4 raised to the power s squared equals 2 raised to the power 5s minus 2. And you have to find the value of s. Now, some type of equation, don't forget, you make both sides of the equation to be of the same base. Here, you're only condensing 4. So we are having 2 raised to the power 2 for 4, and you're still having what? S squared there, don't forget. Equals 2 raised to the power 5s minus 2. And you can see that now. They are now of the same base. So what was the principle? You equate the powers. If they are of the same base. If they are not of the same base, you can't equate the power, they must be of the same base. So we are having 2s squared, this one crossing minus 5s plus 2, then equals 0. So it has resolved to quadratic equation. To solve this quadratic equation, there are various methods you can use: factorization, formula method, complete the square method. But you'll be using factorization, which is the fastest method. To use factorization method, don't forget, use coefficient of s squared multiply the constant, and that will be what? Plus 4. 2 times plus 2 is plus 4. You now look for 2 factors of 4 that you can multiply together, that will give you 4. At the same time, if you add, that will give you minus 5. Now, see minus 5, you should know you can only have something like minus 1 times minus 4. That can give you minus, if you should add, that will give you minus 5. So we are having minus 1 minus 4 to give you minus 5. At the same time, minus 1 times minus 4 will give you plus 4. So all what to do is, whenever you see this minus 5, you replace it with the 2 factors. So we are having 2s squared. Then, instead of minus 5s, place the minus 1s. Minus 1 is written as minus x. So place the minus x, then minus 4x plus 2 equals 0. How do you go by this? You factorize by grouping. So you group this, and if you group this, no negative is outside. So the negative outside, we have fed what's inside. So if I should put bracket, you know, this place cannot be plus again, it should be minus. Because this minus we are affecting outside the bracket. So you should be very, very careful. Equal to 0. Then, from this side, what's common? From the first group, s is common, take s out. What's left? 2x minus s in x is 1. From this side, what's common? You can see it's 2. So take 2 out. And what's left there? 2x, abi? Then minus 3 into is 1. I think you can see that now. Equals 0. You can see 2 terms. Something is common between the 2 terms. What is that? 2s minus 1. So take 2s minus 1 first. Then what's left there? S minus 2. So it's either 2s minus 1 equals 0 or s minus 2 equals 0. And therefore, if you solve for s here, by collecting like 10, we are having 2x equals, that will go to become plus 1. Or from here, you can say s is equal, that will go become plus 2 now. So from here, you can value both sides by 2. And we are having what? S to be equal to what? Half. Or from here, you can simply say s is 2. So from this equation, see that you see it as s is half, 1 over 2, or s is 2. You can check that. Let's consider another example. If 5 raised to the power y plus 1 plus 5 raised to the power y equals 150, and you have to find the value of y. To solve this, it's very simple. You are given 5 raised to the power y plus 1 plus 5 raised to the power y equals 150. Now if you check this one now, notice that this one does not involve multiplication or division. You are seeing addition there. So you cannot just say because they are the same base, you multiply power or you add power. No. How do you go by this question? It's not very easy. find a way to manipulate to get your final answer by applying the knowledge of the laws that you have already. Now to solve this, you notice that something is common here, something is common here. You are seeing 5 raised power y, 5 raised power y. So there is a way you can factor out 5 raised power y. But in this case, you have 5 raised power y plus 1. And don't forget from a multiplication law that whenever you are multiplying, add the power. You should know you can separate this one to be 5 raised power y times 5 raised power 1. You know, this, we still give you this. Then plus 5 raised power y equals what? 150. Now what you notice there, something is common here, something is common. This one is common. Something is common here, something is common here. What was that? 5 raised power y. You can just take out 5 raised power y. One will be left there. Be left with 5 here plus 5 raised power y, because 5 raised power y will be left with 1 here. Equals what? 150. Simplify outside the bracket. 5 plus 1, that will be what? 6. So we're having 5y then times what? 6 equals 150. But don't forget, I'm looking for y. So the only way to look for y here is we divide both sides by 6 first here. So we're having 5 raised power y times 6 divided by 6 equals 150 divided by 6. 6 will cancel 6. So we left with what? 5 raised power y equals, and what's 6 in 150 is easy. 6 in 12 is what? Is 2. Abi? We mean that 3. And 30, 6 in 30 is what? 5. So we're having 25. What you notice, you can see that there's a way you can condense both sides of the equation to be of the same base, because 25 can be expressed as power of 5. So we have 5 is power y. 25 as power of 5 is what? 5 squared. 5 multiplied itself 2 times is 25. And they are of the same base. What did I say? We simply equate the power. So simply y is equal to 2. You can see that. Let's consider another example. If we are given, let's say 5 is power 2x minus 5 is power 1 plus x plus 6 equal to 0. And we have to find the values of x. Now, from that previous example, at least we have seen similar thing that this one is not involving multiplication or division. Just find a way to rearrange and get your answer. So to solve this, 5 is power 2x minus 5 is power 1 plus x plus 6 equal to 0. Now, what do we realize there? You know, you can still separate here. So I can say 5 is power x. You can say it's carrying power of 2 minus, then separate this to be 5 is power 1 times 5 is power x, then plus 6 equal to 0. Now in this case, you know, this one is not straightforward like that one. And even if you factor right 5 is power x out here, there's nothing that we can do. So the best way to solve this is, wherever you see 5 is power s, you will send it to the letter. Because seeing what I rearrange here, you notice that this equation is resulting to quadratic. So the best way is you let 5 is power x to be a letter, let's say letter a. So whenever you see 5 is power s, change it to a. Just like a now, 5 is power s become a. Don't forget this carrying square, that will be a squared. Minus 5 is power 1 is 5 times a, then plus 6 equals 0. You can see that now. So we now be having a squared minus 5a plus 6 equals 0. So it results to a quadratic equation. And I said the best way to solve a quadratic equation is factorization method. If possible, you can factorize the equation. So the coefficient of a squared there is 1 and the constant is 6. Multiply. That will become 1 times plus 6 plus 6. So you look for two numbers. That you can multiply, that will give you plus 6, and that you can add. That will give you minus. You can have 1 times 6 and 2 times 3 to give you what? 6. So I can now go by the addition and it will give you minus 5. You should know that if you are having plus 1 times minus 6, you can't get plus 6, it will give you minus 6. So the only way you can get that is having minus 2 minus 3. Minus 2 times minus 3 will give you plus 6. But minus 2 minus 3, if you add them, it will be minus 5. So you are choosing minus 2 minus 3. Replace minus 5 with minus 2 minus 3. So we are having a squared minus 2a minus 3a. We have changed it now to 2 factors. Then plus 6 equals 0. And you factorize by grouping. So group it into 2. If you forget this negative affects everything inside. You can see that now. Equal to the negative affects, we give you plus 6 back. And take out what's common from measuring. What's common here? A. Take out a. What's a in a square remain a minus. A in 2 remain 2 there. Minus what's common here? 3. And I left with a then minus 2. What's common to both again? a minus 2. And what's left? A then minus 3. So it's either a minus 2 equals 0 or a minus 3 equals 0. And therefore a is 2. If we like, then that one will go, or a equals 3. But this is not your final answer. You have to find s, not a. You have only changed 5 is power s to a. So recall that 5 is power s equals what? A. That shows that you can either see 5 is power x to be equal to 2, or 5 is power s to be equal to what? 3. Yes. Both sides of the question, they are known of the same base. You can see now. So there is no way you can apply the law that I have explained earlier. But there is this solution to this. Then how do you go by this? It's very simple. All what you need to do is you use logarithm approach. Though I used to do logarithm, but to people that have knowledge already, and that is approach. You use logarithm approach. All what you need to do here is you take the log of both sides. So we are having log 5 is power x equals log 2. Similarly here we are having log 5 is power x equals log 3. So logarithm, the power of number always comes to the back. If you have expression like this, so we are having s log 5 equals log 2, or s log 5 equals log 3. And since we are looking for s log 5 divided by log 5 equals log 2 divided by log 5, or s log 5 divided by log 5 equals log 3 divided by log 5. So end of the day, log 5 cancel log 5, and s will be equal to, this log 2 is an example of a common logarithm. And what we call common logarithm? Logarithm of number to base 10. So it's either you use your four-figure table to find the results, or you use your calculator. So if you use a calculator, log 2 is 0.3010 to 4 decimal places, and log 5 is 0.6990. Similarly here, f simply be log 3 is 0.4771 divided by 0.6990, and you divide. Therefore, s will be equal to 0.431, or s will be equal to 0.683. Another example, if we are given, let's say 2 is power y plus 32 into 2 is power minus y minus 12 equals 0, and we have to find the values of y. Now, how do we solve this? We are given 2 is power y plus 32 into 2 is power minus y minus 12 equals to 0. Now, to solve this, you realize that there is a particular thing that is common. 2 is power y, 2 is power y, can see there, but they are not the same yet. So we try and rearrange using the knowledge of the laws we have learned. So here now, we are having 2 is power y plus 32 into, you are seeing negative power here. And what's negative power? I think it's 1 over, don't forget. So that 1 over 2 is power y minus 12 equals 0. I believe you can see that now. Now, to make the work to be easier, you can just say let 2 is power y be any letter. Let's say b. So anyway, you see 2 is power y, we substitute b. So this one will become b plus 32 brackets in as multiplication times 1 over 2 is power y is what? B minus 12 equals to 0. So having b plus 32 times 1 is 32 over b minus 12 equals 0. So same fraction here can have everything to be over 1. And now to simplify the fraction, you can simply multiply through by the LCM of the denominator. And what the LCM of 1, b, 1, and 1? The LCM is b. So you multiply through by b. So let's multiply through by b. We're having what's b times b plus b times 32 over b minus b times 12 over 1 equals b times 0 over 1. So what's b times b? B squared. Here b we divide b. So we are having plus 32 left minus b times 12 become minus 12b and b times 0 is 0. I said that it forms quadratic equation. So let's rearrange. It will be b squared minus 12b plus 32 equals 0. And you solve that. I told you there are various methods you can solve this, but the simplest method is the factorization method. If possible, you can apply it there. And how? Use coefficient of this, multiply this. The coefficient here is 1 times the constant is plus 32. So just look for the factors of 32 that you can multiply together. I'll give you this plus 32, and when you add, it will give you what? Minus 12. Now what are the factors of this 32? 1 times 32 itself, 2 times 16, 4 times 8. If you realize that it will be this. Because if you put negative, you'll be having minus 4 times minus 8, which is 32. At the same time, minus 4 minus 8 is what? Minus 12. So let's replace minus 12 with this. So we're having b squared minus 4b, then minus 8b plus 32 equals 0. And let's simplify further by factorization. Let's do that into 2. So negative we have here, don't forget, so affect what is inside equals 0. And from the first root, b is common, take b out, b in b square remain b minus, b in 4b remain 4, minus 8 is what is common here, take it out, remain b minus, 8 in 32 is what? 4 equals 0. So b minus 4 is common, and you're left with what? B then minus 8 equals 0. So either b equals 4 or b equals 8. But recall that what? From the beginning, 2 raised power y equals b. We are looking for y. So therefore, 2 raised power y equals 4 or 2 raised power y equals 8. So this one is not like that previous one. There's a way you can condense this one to be of the same base. So that would be what? 4 is 2 squared, 2 multiplied itself 2 times, and 8 is 2 multiplied itself 3 times. Therefore, y is equal to 2, or y is equal to 3. And that is the final answer. If I give you something like 2 over 3 raised power x into 27 over 4 raised power y equals 3 over 4, and you have to find the values of s and y. Now how do you solve this? We are given 2 over 3 raised power s, 27 over 4 raised power y equals 3 over 4. Now how do you solve this? It's very, very simple. Once you apply the laws that you can see that this is common power law, where everything inside the brackets will be affected by the power. So you can just first try and separate by saying 2 raised power s over 3 raised power s. So carry it. The same thing here. Bracket multiplication. And that 27 raised power y divided by 4 raised power y equals 3 over 4. Now, having that in mind, you should notice something that there's a way you can interchange so that the one of the same base will fall to one category. So like here now I can simply say this one is set as 2 raised power s divided by what? 4 raised power y times 27 raised power y divided by 3 raised power x equals 3 over 4. And you can see that still the same thing, still multiplication, so that we can condense and apply division law. So we're having 2 raised power x divided by, let's condense 4, 2 raised power 2y times 27. 27 will become what? 3 press it 3 times. That 3 raised power 3y divided by 3 raised power x equals 3 over 4. Can I apply your division law here? So let's apply it. We're having what? 2 raised power x minus, no use of classical division, 2y, then times 3 raised power 3y minus x. I really can see that now. Equals 3 divided by 4. Now, this particular equation will result to Samplon's equation. And here, there's a way we can separate this one too by saying we're having 2 raised power minus 2y times 3 raised power 3y minus x. Then you can separate this one to be what? you can say 1 over 4 times 3 over 1. You can say see the same thing as 3 over 4. Then you can try and condense so that it will look like the one at the left hand side. And what's 4? 2 raised to power 2. And why is 1 over? I told you it's negative power now. The reverse. That is, this one is written as 2 raised to power minus 2. Now it's written as 1 over 2 square, which is 1 over 4. Then times 3, which you can say raised to power 1. 2 raised to power s minus 2y equals 2 raised to power minus 2. And 3 raised to power 3y minus x equals 3, which you can say raised to power 1. So you can call this one equation 1, I can call this one equation 2. So from equation 1, you can see that 2 are of the same result in this equation. That implies that s minus 2y equals minus 2. You can see that now. So let's call this one equation 3. And from equation 2, you can see that 3y minus x equals 1. Multiplication by negative, we are having minus 3y plus x equals minus 1. Which can be arranged to be x plus x now minus 3y equals minus 1. So let's call this one equation 4. So let's joining equation 3 and 4. We can now have something like s minus 2y equals minus 2, equation 3. And we can have s minus 3y equals minus 1, equation 4. Then we solve that simultaneously. So that you use elimination method, substitution method, graphical method, or any other method that we can use. But here we'll be using elimination method to make our work to be easier and faster. Let's solve the two simultaneous equations. We're having this equation 3, and we're having s minus 3y equals minus 1, equation 4. Here you eliminate a variable to solve for the other. And the first variable we eliminate here is s, since there will be same coefficients. So let's subtract equation 4 from 3. So s minus s will give us 0, minus 2y, then minus into minus 3y. This minus is here, this minus is here. Equals same thing here, minus 2 minus, having minus 2 minus, having minus 1. So minus 1, you demarcate 1 out of it. So let's open the bracket first. We have minus 2y, the minus is supposed to become plus 3y equals minus 2 plus 1. And what minus y plus 3y? Y. Minus 2 plus 1, that will be minus 1. So therefore y is minus 1. And you put y equals minus 1 in any equation, like let's say equation 3 above now. So anyway, we see why we put minus 1. So we're having s minus 2 instead of y now, we're having minus 1 equals minus 2. Open the bracket, minus 2 times minus 1 will become plus 2 equals minus 2. And collect that terms. And take it down to the other side. Now we're having s to be minus 2, then minus 2. And this is going to give us minus 4. Therefore, s is minus 4 from the equation, and y is minus 1. As simple as that.